Alright, so this is section 1.3, vector equations. And in this section, the main result was that if you have a vector equation that looks like a linear combination of vectors a1 through an equals a vector b that has the same solution set as the augmented matrix with the vectors a1 through an, and b is columns. So that means that b can be written as a linear combination of a1 through an if and only if the system corresponding to that augmented matrix has a solution. Alright, so let's look at an example. Is this vector b in the span of UVW, where u is the vector 1, negative 2, negative 4, v is the vector 2, 3, 1, and w is the vector 4, 1, 2. So we can couch this as a question with the matrix. So can we find scalars x1, x2, x3 such that x1u plus x2v plus x3w equals b? This is the same thing as asking what is the solution set to the system corresponding to the augmented matrix that has u, v, w, and b as columns. So here's the matrix. So what do? We need to row reduce this matrix and see if we can get a solution. So let's do it. So here's the matrix. Now remember, I want to start by getting a 1 in the corner, which I've already done. So the first thing I'm going to do is replace row 2 with 2 row 1 plus row 2. That gives me this matrix. Now let's eliminate the negative 4 in row 3. Now we have this matrix. Now notice in row 3 everything is a multiple of 9. So I'm going to switch row 2 and row 3 so that then I can divide everything in row 2 now by 9. Okay? And that gets me a 1 in the second position. Now I'm going to eliminate the 7 in row 3. And now we're going to divide everything in row 3 by negative 5. Okay. Alright, now we want to work up and eliminate the things above the 1s. Okay, so I want to eliminate the 2 here above the 1 in the third column and the 4, and then I'm going to eliminate the 2 above the 1 in the second column. Alright. So row 1 gets replaced with negative 2 row 2 plus row 1. And now we're going to eliminate the 4. Alright, so now I have the matrix in reduced row echelon form, and if I write the system of equations, that means x1 equals 2, x2 equals 2, and x3 is 3. So I can write UVW as a linear combination and get B. Okay, so these are the kind of things that you're going to be doing in this section. Think about what happens when you write things as a linear combination, and how do you convert between writing them as a linear combination and looking at the augmented matrix.